Alright, so this is a quick demonstration of some of the FSK process data that are received from the software-defined radar. What I have is on the x-axis here we have time. So this is I believe it was a 10-second recording of me walking down a hallway. That's from 0 to 20. I pause at the end of the hallway from about 20 to 40, and then between 40 to 60, maybe 40 to 65, I'm walking back directly to the radar, and then I turn around and sit back down at the computer. There was just a few seconds left. The x-axis is not to scale as far as seconds, but it's just there to show the linear progression. The y-scale is with the FSK data. What I've done is I have I split the signal in half. We have the first frequency that's transmitted, then we have the second frequency that's transmitted with a 6 megahertz offset. So the signal is split in half, and then I pick a particular index of that signal, and then I take 64 of those signals and I run an FFT. And so that's your y-axis, and it's zero padded out to 4096 just so that we can actually see some stuff going on and it's not so tightly packed. So that's the y-axis there. The label here will say FSK velocity plot, signal index 64 of 64. So in this image, I'm using the 64th point of that split signal. And when I say 64, I think the transmit option or the receive options were 128 samples per sweep, 256, 512, and 1024. So in this case, I used 128. It's split in half, so each frequency has 64 samples that it collects from. Alright, so we have negative velocity would be on the bottom, positive velocity would be on the top. So on the bottom I'm walking away from it, so we have a negative. The axis isn't set up right, this is just a demonstration. So you can see the main amplitude of the main signal is my body moving away from the radar. These top and the bottom lines that you see are going to be my arms swing back and forth, or my legs. I'm actually not sure which one it is, but it's going to be one of those. What I wanted to demonstrate was that it doesn't seem to matter which index we pick from. I know in our in the FSK processing stuff that we're doing now, we go ahead and we try to pick the one with the maximum return for velocity, and then we use that to calculate range. So I'm going to play a loop now where I go from the first sample all the way up to the last sample in that stream, and you'll see that you get just about the same thing throughout. So I'll go ahead and start playing now. Actually, no, I need to let me make sure this only shows up on the video. So I will disable figure 2. Sorry, just a quick change. And okay, go. So it's kind of quick, but I'll start it over. It's going to go from signal index 1 to 64. And you'll notice that the only thing that really changes is just the background noise, or the noise floor. But the main return doesn't move, doesn't change amplitude. It's relatively the same throughout. I'll play it one more time. Which is cool, because actually we can take this and we can take those, all of the sample indexes 1 through 64, we can take the mean of it to really clean up that signal. I'll show that in a little while. I have another figure that I want to show. I didn't prepare all this in MATLAB, so let me just clean this up. Alright, so this is going to be a 3D image. And so you can see it's the same figure, it's warped a little bit. I think it's flipped as far as the positive and negative velocity, but it's the same general thing. But it's going to be on a 3D scale so that you can see the noise floor rising and falling. So I'll go ahead and play through all the indexes now. Alright, it's all done. And you can, if you noticed, the amplitudes of the main returns don't change, just the noise floor sways. So I'll play it again. Alright, great. So that is all 64 samples of signal 1 and 2. What I can also do is I can also show that if we take all 64 of those returns and we process them, oh, that kind of blew up, we process them individually, we can take the mean of it, and we end up with a slightly cleaner signal. The downside is this would have been, I guess, a lot more processing because you're doing so many FFTs, but it clears it up a bit to the point where you can even see my hand swaying left and right up here. And there's no fancy processing going on with this. This is all just FFTs and means and maxes and stuff. And there's the mean image compared to this one right here. So it's not much of a change. I think the noise floor dropped, and then the main signal amplitude dropped from 60 dB to 20 dB. All right, that's all. Thanks for watching.